Ooh, there we go. Welcome to another episode of the exercise application assignment. Woo! It's a Tuesday, and I'm wearing the same shirt as the last two videos, but this is a different day. Trying to make sure I stay on track with this. I'm getting frustrated. I think the real reason I've been struggling to stay on track with this, gosh, is because my videos are literally struggling to upload to YouTube, and so that's frustrating because then a video won't upload, and then I have to go back and see which one didn't upload. So it's very frustrating at the current moment. But you know, we power on, we pull through, even if we have to film a video without wearing pants. So we moved on to cardiorespiratory physiology. I feel like we did not cover half the stuff I thought we were going to cover with hormones. Honestly, I'm going to go back and review the big bullet points of hormones that were covered in the PowerPoints and the videos to get a feel for what I need to be focusing my energy on. So let's talk about what I did today. Today was lats and triceps. Felt very, very good. Started out with some wide grip lat pull downs, progressing swimmingly with that. I love the grip adjustment. The grip adjustment feels very good, and I'm doing this thing where I'm able to get a greater stretch on it. I don't know exactly what it is, but it's almost like it's a very traditional style, the Franco Columbu style, where you're pulling very straight up and down with your pull downs. But I don't know, it's almost like I'm able to get a better stretch in some form or fashion. Then I did some single arm hammer strength machine rows. Then I did upper back focused hammer strength machine rows. So like this, and it always reminds me of that meme where it's that guy and it's like how bikers eat their sketty, and he's holding up 2 forks and has pasta noodles off the sides. It's like biker handles is so stupid. And then after that, what did I do? I moved on to triceps. I did some easy bar French press. Moved up to 70 pounds on that, which is good. 70 pounds for 13 on my top set. So definitely going to be going up to 75 next time. The French press felt superb today. And then I did some, single arm tricep push downs. Then I did 1 set of lat prayers with that bar that I like, that shape like choop, 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 choop. Feels very good. It's just kind of like a little finisher on the lats and triceps. And then I capped off the workout with some heavy shrugs. So I did like 255 pounds on my top set. Snatch grip shrugs, so wide grip, you know. I like those. It always looks like I'm ego lifting when I do them. But I'm doing them with fairly strict form, using a full range of motion. And I'm really just emphasizing that stretch. Really, I would like to do a power shrug, but that's sometimes looks a little bit silly. It's kind of frowned upon by a lot of gym goers. So let's go. Let's dive through it. I'm gonna run through all my notes. I don't care how long this video is really. I mean, a little bit, but I want to make sure that I'm having some sort of idea coming here. So when I train, right, we have our different types of hormones. We have lipid soluble, we have water soluble. Lipid soluble is going to pass straight through into an intracellular transporter. Blood hormone concentration is regulated by secretion rate, hormonal excretion rate, transport protein quantity, and changes in plasma volume. So let's talk about how that relates to exercise. Then we have our slow-acting hormones, right? Steroid will diffuse through the membrane, binds to a protein receptor inside the cell. Steroid receptor complex enters nucleus, binds to polymerase 2 on the DNA, transcribes RNA, messenger RNA, to communicate with ribosome to form a protein. Second messengers, you have your hormone binds to an extracellular receptor site. G protein is activated. G protein activates adenylyl cyclase, activates CAMP, which activates PKA. We have a response protein, and then we have our cellular response. So this is the mechanism by which the hormones that I am producing through training, because I train heavy on some sets. I do 1 set, you know, my top set is usually my heaviest set. So that's usually where I'm getting the greatest hormonal response. My subsequent sets, which could be lighter, you know, okay, relatively, let's think about it like this. If I start out, usually, my top set, by heaviest, I mean like, it is the heaviest numerical weight that I'm using, right? I warm up and then I hit the heaviest weight that I can. Now, how many reps that is? It could be 10 reps, so it doesn't fall within that hormonal range. But my subsequent sets will be less reps. So then I think that does fall within the hormonal range, right? Of like 1 to 5. You know, your T response, your GH response, resting in between sets, right? You're going to have a better testosterone response from heavy lifting. Heavy, intense lifting, you know, in terms of intensity. Anterior pituitary hormones. We have ACTH, FSH, LH, MSH, PRL, prolactin, TSH, and GH, which is regulated by GHRH in the hypothalamus. Insulin like growth factors can be emitted from muscle tissues as a result of contraction via autocrine and paracrine mechanisms within the muscle. Hypothalamic somatostatin inhibits GHRH. So if we're talking in exercise, growth hormone production, right, which is if I have short rest periods or high intensities, that's going to spare my plasma glucose by opposing insulin, increasing the synthesis of new glucose in the liver from aminos, glycerol, and lactate. What's that? Gluconeogenesis. And lactate. So that's going to be a Cori cycle. Increasing the mobilization of fatty acids from adipose tissue for fuel source. GH stimulates protein synthesis post-exercise. Whoa. We want that. We want that post-exercise. So if we're thinking about GH, get protein synthesis, blocks glucose entry into adipose, favor fat metabolism. Favoring fat metabolism, we're keeping our blood sugar up. So that's also keeping our brain alive while we're exercising. Posterior pituitary, we got oxytocin and ADH. We got pissin and lovin and pissin. Thyroid hormones is going to regulate our overall metabolism. During exercise, T3 and T4 release from plasma protein. The release from plasma proteins. TSH secretion increases to compensate for T3 and T4 being taken up. So what does that mean? Let's think about what that actually means and verbalize it so we act like we know something. I think I can't post videos longer than 15 minutes on YouTube, so whatever. I'm going to try and run through this, though. So what does that mean? I think that has to do with the appetite increase after exercise. It's saying, hey, you're fucking shit up here. Oops, I said a bad word. I'm going to get demonetized. Hey, we're receiving some heavy damage. You need to eat to compensate for this damage. Go get some protein. Skinny bitch. Let's see. Calcitonin, adrenals, adrenal medulla. Epinephrine and norepinephrine are both sympathetic nervous system hormones, but norepinephrine is the primary norepinephrine is the primary neurotransmitter and is more powerful. Okay. Adrenal medulla, that's what that does. E and NE stimulate muscle contraction, binding to an adrenergic receptor. Acetylcholine inhibits. Yep. Let's see. Talking about the different receptors, we have beta 1, 2, and 3. I think the basic idea here is that if you bind to a beta receptor, your heart rate goes up, glycogenolysis goes up, so we're cutting up glycogen, getting glucose. Lipolysis goes up. So we're breaking down breaking down glycogen, putting some more glucose in the blood, and breaking down free fatty acid, mobilizing free fatty acids. Binds to an alpha receptor, right? The phosphodiesterase system goes up, vasoconstriction, and it opposes the beta B1 and B2. So your insulin secretion is going to go down. So you have our mineral corticoids, aldosterone, renin-angiotensin system. We know that it's going to kind of help maintain our blood volume. Cortisol response to stress, including exercise. To ensure that fuel, glucose, and free fatty acids are available and aminos are there for tissue repair. So we're mobilizing tissue amino acids, mobilizing free fatty acids, stimulates gluconeogenesis. So when your cortisol is too high, you're using your amino acids for energy, which is bad, right? think that's the implication there. Right? If it's too high outside of exercise. Because if your cortisol high, we're mobilizing your amino acids. Certainly post-exercise would be used to repair, but then the rest would be converted to energy. I'm assuming. I'm still unclear about that a little bit. Maybe I just need to hear it said a different way. I probably watched the video lectures. I need to do that. I need to get on that, because with these 2 units so far, cardiorespiratory and endocrine, I am struggling for some reason. Insulin secreted from beta cells. Let's see. We have like 5 minutes left. I'm gonna kind of testosterone. Okay, let's go over that because that's big. I mean, yeah, T response at 85% of 1 rep max. And 2-minute rest periods. GH response greatest with low rest periods. Estrogen, progesterone. Whatever. No one cares about that. Glucose concentrator, plasma glucose, the main fuel source of the brain. They're also protected by 4 mechanisms: mobilizing existing glucose from liver glycogen, mobilizing free fatty acids from adipose tissue to spare plasma glucose, synthesize new glucose from aminos, glycerol, and lactate, gluconeogenesis, block glucose synthase into cells, right? So what is it? How the hormones do this? We have the catecholamines, cortisol, GH, glucagon, and insulin. Insulin is, out of all those, insulin is the only one that encourages uptake. So it does not preserve your plasma glucose. Also glycogen utilization. So that's through 2 mechanisms. You have epinephrine binding to a beta receptor. Second messenger system activate phosphorylase B, which in turn activates phosphorylase A, glycogenolysis. And then we have glycolysis. Or it can be through the calcium in the muscle. Blood glucose homeostasis during exercise. Yeah, you know that. Because of its slow-acting hormones. Okay. Let's try and cover some cardio content. So we have the heart. So let's walk through. P wave. The atrial begin depolarizing. Atrial depolarization is complete. We can also say atriosystole is complete. Then we have ventricular depolarization / atrial repolarization. So that's our Q to R. So that's going to be ventricular systole happens at the same time as atriodiastole. And then we have a complete at the R. And then R to S is going to be the completion of ventricular depolarization. And then, so ventricular diastole is from S to T. So, yes, okay. Then we have all the parts. Interpolated disc, transmitted electrical pulses. So when I'm living, when I'm exercising, right? Your heart, we have our SA node, which spontaneously emits a pulse, and then it propagates down the cardiac muscle through the intercalated disc of the cardiac muscles, propagates down. We're having that wave of contraction, and then it hits the layer of connective tissue, and it dissipates, stops. But it hits the AV node. The AV node kind of trickles down into the right and left bundle branches, which goes down the interventricular septum, which comes up around with the Purkinje fibers and stimulates that wave of contraction from the bottom up in the ventricles, which in turn shoots the blood in either the systemic pump or the pulmonary pump, right? Which we need. So then, what about my heart rate? Heart rate during exercise. Or blood pressure. Let's go blood pressure first. Blood pressure is influenced by blood volume, heart rate, stroke volume, blood viscosity, and peripheral resistance. Now, most of those things are not going to change very much, but heart rate and stroke volume will very much change with exercise. But when we talk about peripheral resistance and how that happens, right? I'm skipping ahead. Oh my gosh, I'm running out of time. I'm gonna have to cut it off here. Maybe in the next episode, which I will be filming hopefully tomorrow, I will cover more content. I'll see you in the next one. Oh my gosh. Stop the fucking...